Hello, so here we have another type of video showing you when to stop reverse engineering, because reverse engineering is quite a profitable hobby if you want to work on Upwork, for example, but sometimes offers just look too good to be true, and initially you cannot say anything about if you are able to do the work or not, because you would have to do initial research. So there's always this risk of, let's say, yeah, I accept the job without knowing if I can do it. And then I have to figure out for myself how much research do I put into this before I have to say, no, I cannot do this, or this will be way more expensive than initially planned, or something like that. So when to stop? Let's find that out. The example I have here is from an actual client I had on Upwork that asked me to fix the screen ratio for his game. In this case, FIFA 2006. The idea is the following. Let me make a little picture. Yeah, whatever. I have on the one hand FIFA. Quickly check, that was 07, okay. So FIFA 07, for which we want widescreen support. There already exists a plugin for it. And it should just be expanded to actually not just offer the resolution, but also to actually fix the ratio for it in the menu. So expand it to fix ratio as well. This is one game. Then we have another game he is talking about. Let's see. So I can provide a widescreen fix and source code from a closely related title from the same era and publisher as reference. So the idea is, at the same time there were multiple sports games that came out at the time, and so the idea is the same. Developer will probably reuse the same code, and so if you already know what to fix in one game, you could just try to refine it in the other game and expand the code to do the same. So just to show what the problem actually is, just notice, for example, this EA logo here. It's square right now, that's how it should be, but when it gets on a higher resolution, it actually gets squished. So the ratio between width and height is essentially not kept here, and this is actually a problem of the camera, of the frustrum, I think is the right word for it. Let me quickly Google that. Viewing frustrum. Yeah, okay, that's pretty much already all I need to explain here. So when you have a camera and you want to render anything, you obviously need some surface to render on. And for 3D scenes, essentially this comes from a specific distance to the camera, because the camera is always a point. That's not a surface, so we need at least some distance to it. It's called the near plane, to have a plane that's actually with some width and height. And there's another one that's a far plane, that's as far as something can be rendered. Basic rendering is just move your whole world into this frustrum and then render it onto this plane. So anything that's in this volume here can be rendered and will be seen on screen, if it's not hidden by something in front of it. And so the idea is that the ratio of the height and the width of this plane matches the resolution of your screen. The problem is that let's assume you have a square rectangle as a plane. then you want to render it on a screen that has a different ratio that is square. So what the graphic card is doing, it's just stretching it to the screen resolution independent of what the original resolution was. So that's why this squishing happens. What should be instead is that besides the screen resolution, also this plane height and width is adapted when changing the resolution. And it seems that's not happening for FIFA. Let's go back. So he gives quite a few links for anybody who wants to try this on their own. Where you can, so you first get the game, okay, then you get some, let's say, plugin loader that is an DLL, a third-party DLL that you put in and which allows you to load more DLLs as a plugin. So then we need a specific version of this exe file. And finally, there's already a plugin that can change the resolutions, but it's not changing the camera yet. So that's what we have for FIFA. Let's continue with the other game. The other game is NBA 07, where we have lower please, where widescreen support already exists as a plugin. So widescreen support plus camera fix. Oh, come on. Oh, I can't mark anything here. Okay. Already exists as plugin. And nothing to do here. So the idea is, do I have a picture of FIFA 07 main menu? Oh wait, sorry, NBA. We already have FIFA. So this menu is totally different. It's it has a from the makeup of the scene. So you have upper bars, then you have some buttons on it, then you have the main list with its own stuff in it. You also have a list here, but no bars and stuff. So the thing that is known, as far as I can take from the messages, is that they internally use the same what's it called, UI framework that is responsible for making the layouts. So if you, let's actually make a layout for one of these, so I can explain what I'm talking about. Okay, so first off, you have obviously the whole screen, so I don't need to mark this. That's given. The first thing we draw on it is probably the background image, so also not very needed to explain. Then we have the upper bar. Can I make this a little bit bigger? The lower bar, which is probably just a sprite. Inside this bar there is, as a child in a hierarchy, this logo, these buttons, and so on, which in turn are also split up into the text part and the icon part. Then we have a main panel, let's say, where the list of menu options are displayed, which first has a header, then has the list area. In the list area, each element has its own panel, which has the background or non-background image plus some text and so on. You could write that down as a scene tree. So let's see. Let's see, root is the whole screen. Then we have the background image. Then we have the upper bar, lower bar. The lower bar then has the logo, button 1, which in turn has its icon, its text, and same goes then for the main list, which has its logo, header, the list area, which has elements, which have background image and text. So as you can see, the whole scene that is rendered onto the screen is essentially just a tree that could be essentially walked through. You just go node by node to get the thing that you want to. You could, for example, find out how to access this list in memory by reverse engineering their UI framework and how it's saved, how you can traverse it, and then, for example, just fix this one logo. And you would have to go to root, main list, lower bar, logo. So that would be your path to go. And if you reverse engineered how its structure is in memory, then you would change its width and height. So this is how the scene is structured here. If I would do the same thing for this menu, it would be obviously a lot different. And you cannot take over just assuming I will find that logo at the same path in the scene as at the other game. That won't work. Another thing is both of these menus to render this have to obviously need a camera. Even if it's not 3D, it's still... Do I still have the frustum open? Ah, never mind. It still has to render this into a camera. And you could definitely find the function that is responsible for the camera because it uses unique constants that are used for perspective ratios and stuff like that. The next thing is we could assume that they use the same functions to create the menu, so we could just hook those functions and see how the menu is actually created. So we would get out essentially something like this for the menu. Then there's also the idea that the underlying game engine that does all the actual 3D rendering, loading the scene, doing the animations and sports, is also the same, which is a little bit unlikely because the type of animations in this game are a little bit different in perspective to the ball. So you have animations that can each for one player, many different animations for whatever moves they can do currently. Just one is in soccer, one is in basketball, and the dynamics with the ball, for example, I assume are a lot different for basketball than for football, even if it sounds a simple physics problem. But the underlying engine would probably be different. There could also be the case that they just used the same framework and wrote for each game their own engine. Okay, lots of talk. So we have the resolution plugin, which gives us a resolution to choose from but doesn't fix the camera. We have NBA, as you have seen, which already has a widescreen fix, and we also have some source code for it. So let's maybe start with this. Usually everything starts at main. So there are some, because this is using the plugin system that is loading the plugin, this ASI loader, it has some functions that are given from the plugins. So you get, for example, the entry point address for the... Remember, this DLL is loaded when the game is started. So it will check the entry point, and just by checking if it's at a specific address, it tries to detect if this is a correct game, that you have the right patch value. Another thing it checks, it gets a float value at a specific address and checks if it is one of the expected constants. Depending on where that is in the memory, it knows which version to patch. So this means this is pretty similar between the games, I assume. And let's check out how the 07 version goes. Again, all these patch functions come with a plugin system. Redirecting a jump is just if the code ever gets to this address, go to that function, send it there. So we replace a few functions here, quite a few. This is different resolutions, IDs that are set in a list. So this is probably the list you have in memory that you can choose from which resolution you want to display it. And then we set a lot of values at specific memory addresses with a hard-coded resolution X. What was that again? It's of code. Okay, so this is, I guess, a default value they want to choose. And you can probably set that in some ini file. Great. This is a list of resolution we want to support. And let's have a look at, oh yeah, and also from the comments we can see we changed stuff probably in the scene itself about the bar and stuff like this, where you actually change stuff in the scene itself. This is just a list that is somewhere in memory. This is stuff that's actually in the scene right now, rendered and will be adjusted. I assume, because I haven't written that code, and what it actually does I will check in a second. The next thing is we have these replace functions. They are coming all up here. And you can already see this is essentially code that was copied from IDA Pro, because that's how it names stuff and comments, stack values, stuff like that. So this was taken from IDA and then somewhere adjusted. As far as I see, this is view matrix stuff, and that is responsible for the frustum of the camera. So aspect ratio is literally width by height, and yeah, we put all these matrices together to actually set the camera and update it to the right ratio. So it has the same ratio as the screen, and then with the pixel resolution that we have, it doesn't get stretched anymore. I guess this is some hard-coded function that will set the camera somewhere. Set perspective projection, yeah. Set test, not quite sure what this is doing. This is probably a test if a triangle is inside the frustum, which doesn't have to use the view matrix to detect that, and probably has to be adjusted as well. And then we have something in the interface renderer. Yeah, don't know what this is doing, but the idea would be we find the same functions in Fifa and try to just run these same functions and see if it helps. Obviously we have to refine a lot of functions for that, but if they somehow use the same source code, we could be lucky, and it's easy to refine stuff by just compare reversing. Broadcast mouse input, probably also relevant that your mouse position on the screen is has to be adjusted by the screen ratio. Okay, crazy. So that's what it's replacing here. And let's actually test this. So I think just like this. Come on. hate intros. Options. Where was it? Here? Nope. So these old games. Game resolution. So let me see. I think this is the best I can display right now. Will it actually apply it? Good question. So the menu is very small. I mean, at least this is square, so that is fine. Okay, I have no idea how to play this game. So let's get out of here. Anyway, it's running, and this means we can actually debug it. So let's see how that looks like. This is 32-bit, I think. And it instantly stopped. How's that? How about we just attach to it? No, that works. Okay, so we can see what's in memory now. Here we have our NBA. That's the default offset memory. Actually, I can probably quickly see that here. What was the plugin called? Okay, here we are again. So I did not apply this to NBA 07, so it was kind of pointless to start it. I can show it on FIFA. You have this direct draw DLL which is actually the ASI loader, which then has a plugins folder where you have the actual plugins to be loaded. Each of these ASI files is actually just a DLL, so you can throw it into IDA and compare. We can also throw NBA into IDA and just see what happens at the places we saw in the code. What? Okay, give me a second. Why is this trying to open this with IDA 64? How about this? Okay. So obviously I did some pre-work here. This is executable of the NBA game. Let's go back to this here. And we can, for example, check what happens. Let's try this offset. Go to here. So we put a jump here to replace another function. So this was the original function, and it gets placed with this one. Okay, don't get me there. Okay, so just for compare. Here you have your constants again. You have this unknown. All the stuff is similar, but we have some specific different math here. And we could just go by this constant and try to refine it in the other game, for example. But okay, let's continue some other stuff. Redirect jump. Yeah, +1. I don't understand why it's always +1 or +4. But let's see. Let's add that place. What was the exact address? FC. Okay, so okay, it's just overwriting this value. So, so this is editing assembly. Let me demonstrate that in the debugger, because I don't know how to edit stuff like this in IDA. Sorry. Start. Yeah. New attach. And we can check it here. So if we wanted to, for example, change this to, what do we want to change it to? Resolution Y. So first off, what's that in decimal? That's 480. So, and it's supposed to be height resolution. Yeah, that's already the one we set before. So 640 by 480. And let's just give it another value, just for fun. Boom, and as you've seen, only these bytes have changed, because only this is the opcode and this is data in the opcode. And so it writes its value here and changes this opcode. When it's executed, this will change stuff. Okay, nice. Guess I keep that open for other stuff. So anyway, we can go through everything here and see where we are, what we're changing here. And if I look at this function here, I can also see it's using some imported functions that should not have many references, so it's easy to refine. Okay, that's about NBA. Now let's look at the other side, which is FIFA. Does it work on the first try? Of course not. So this. In here, we want to refine the stuff. Actually, let me stop this and instead start FIFA. So we already know we have the RZ loader installed, we have the plugin which changes resolution already, and we can figure out what this does by, why is it not here? Here, by opening this file. Just for understanding, if I open this with an hex editor, this is just a regular DLL file. So I can also open this in either, if it lets me. And I've already done a little bit of pre-work here. This is the main function of this DLL, and I renamed some functions by what I assumed it's doing, because I checked this in the debugger to see if this actually is happening. So we have a resolution list with different resolutions. There's quite a lot of them. And we write pointers to this list and stuff like this at different addresses. Looks pretty similar. We also change some functions, but most of them are just either jump out functions. This is an actual replacement which checks, probably replaces a function that is returning the, I guess, first available resolution. Okay, so we have this function, also just a jump out, this function. Can you follow that? No, that's in the exe file. So these are just plain redirects, and we have another one here which calls a function that probably returns if this ratio is less than 1 to 5. So yeah, and then calls some internal function from FIFA. So overall, this isn't doing as much as this. So at best, it's replacing some functions, but the functions that are replaced here are definitely more complex than the one in FIFA. At best, we could look for this one here, because this constant is pretty universal for, or unique, let's say unique enough for finding it at memory. It's a float value and it has only 4 bytes, so let's find that one. Also we can just check for this. Sorry for interrupting. Are we using this actually somewhere? Oh, there is code for that. Interesting. Create window A. Well, this is pretty similar. This is just creating the window for Windows itself. Setrect isn't even called here. For the RC. Oh no, it's defined here. Oh, it inlined it. Okay, this is actually the same code here. So okay, we actually found something back. A window name isn't set yet. Will it be written somewhere? What's it writing? Ah, this isn't a function yet. So let's make it a function, pressing P. Real application. Okay, that's probably not it. How else do we write this? Yeah, real application. And we write it here. Okay, by whatever this is called from. Yeah, FIFA 07 demo. Okay, interesting. So we can refine software. That's good at least. But this is very low level at the start of the main function. This is before any engine starts. But I was looking for that constant. Yeah, that one. Let's actually see what that is in hex. Let's open this. Wait, what? Let's copy this to assembly. Is that the value? Zero 00870. That's definitely not it. I hate float math. Here it is again. 0.5. And we have ton. Here comes it. Ah, there it is. Okay, so these are 4 bytes. That should be very unique. Let's test it. See how often we find it. Once. Okay, that is great. Let's try to refine it in Fifa then. And there it is. It's in a similar function. So this function, as far as I've seen, hasn't been replaced yet. So this would definitely be one of the functions we have to recreate to get to something like this. Finding those other functions, that is a whole different story. You could, for example, follow the code to see which where the mouse input is going to, and then follow that path to see if you get to any function like this, but unlikely. And then we have a lot of stuff like the load bar and other settings that are specific to NBA, that are definitely not specific to FIFA. And so, assuming this would be another scene walkthrough to change one specific thing in the scene, this would have to be done redone for FIFA to be able to do the fix for the logo, for example. And well, maybe we could get away with just fixing the camera, but I'm sure all these other functions were replaced for a reason. So there's that. And also you would have to write new code for this. This will take a while. And overall I spent like, I don't know, 2 or 3 hours to get to this state of how my code looks like. For example, where was it? This one here. This took me quite a while because I had to obviously start the whole thing in the debug. Let's actually try that out and find that function. We have last one. FIFA, please. 1 EDO. Is that already one? Oh, that's already. I made a breakpoint there. How convenient. How would I actually refine that? Many ways. I could obviously take a few of the opcodes and just search for them. So one of these opcodes here obviously need some bytes, and I could just look for that pattern. But sometimes values could be replaced because of the DLL getting located at different addresses in memory. But never mind about that. I can then, for example, assume that this address will get written the pointer to that list, so whatever value that is. And I assume the 1 is only that it does it once. I'm not quite sure what that value is for. Let's check. A3, B6 goes in here, goes in here. Yeah, I don't know, to actually write it, otherwise it writes 0 bytes. That is kind of weird. I don't know who wrote that or why it compiled like that, but let's see if that's true. So the first one would be this call. So we give it that address that we want to patch. Let's actually look that up. And disassembly. So this looks like crap because we're in the middle of an opcode. So let's scroll up and back down. That's actually the area we want to change, it seems. So quick check. 4.8. So yeah, skip the first 2 and then change that value that is at the end here to whatever new value we think it should be. So to see that this value changes, we watch it in the dump. Sorry. Like this. So we have the E4, the 42, HC and 00. And we assume if we step over the function this will change. See, bam, 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 all change to the value we got on the stack. So it just writes it dewords there. And that's pretty much all to figure out what this function does, what this function does. These are a bit more complicated, but you will find out that you come out in the middle of opcodes, so this just insert jumps or changes jumps. And yeah, I think there was, so yeah, here's no function at no point replaced that would change something about the screen resolution, so you have to write another plugin that does all of this plus where is it? So write all of this plus the other functions here that you have to find, plus finding all the scene references to your logo. So at some point you can then fix that logo to not be squished. All the stuff like this going together. So again, I spent like 2 or 3 hours to get to the state to have everything downloaded, started, being able to debug it, then verify what that code does, and see what the other code does already for FIFA and how it would be expanded. And now let's finally go back to the actual initial offer his budget is just $500. So that sounds like a lot, but if you think about, I take like $50 an hour, this would be 10 hours of work, and I already spent like 2 or 3 hours just to be able to tell him, yes, I will have to write more function for this, not just fix a function that calculates the perspective and set the values here and there. I can tell you that I will also have to find out where in the menu scene the object is and fix that by hand. So that needs a lot of debugging and reverse engineering how that UI is actually created. And you will definitely not do this in the next 6 hours or 5 hours or whatever. So this is a point where you have enough information. Well, I lost like €100 of work here, but it's better than putting in €500 of work just to tell them, yeah, I cannot finish this with this budget. I would need way more money for this, way more time, and this I have to give up, and you lose the whole 10 hours of work. So that's the point. That's where you have to just initially get all the information that you need, make yourself like little notes how stuff are supposed to work together. Why is this red? Whatever. To understand, oh yeah, I forgot to draw in here that there's also the plugin loaded in here, and that you can essentially tell, okay, what is the scope of this project? Is it really just all the functions are easily refined in NBA, for example, and then refine them in FIFA just by that constant? And how easy is that? We can already see these are totally different functions that in the end will probably do the same but are made differently. So the base code behind this is definitely different, and so you have to actually start from scratch and reverse engineer FIFA to actually get to the point where you can understand enough to change the menu and find these functions relevant to mouse inputs and stuff like that. So yeah, this was one of these projects where I did spend time that I could not recover, but I made this video about it, so it's not totally wasted. And I can show that how far you should go before you just say, yes, I can do this or I can't. There are a lot of projects where it's possibly where you can the whole time not say if you can finish it, like if you try to reverse engineer some encryption or obfuscation or something like that. Until the last moment, you will not be possible to tell. You will not be able to tell if it's possible. And yeah, getting a quick overview into the project and quick debugging to get the information you need to make a useful response to it. That's a skill that definitely, yeah, you get over time if you do multiple jobs like this. And after time, it comes quite a profitable income if you know, oh, this is something I can actually do and finish. And this is one where I'm not sure, and I set a bar how much I want to spend on it before I just say, okay, I cannot do this either in the time, or my skills are lacking, or it's just not possible. And yeah, do that fast so you save time. Alright, I hope this helps a few people out there that try to do reverse engineering for money. And otherwise, well, if you want to continue this quest, this is a start information. You can just continue from here and take all the information I already found out and continue with finding out more. Alright, thanks for watching and have a nice day. Bye.